In this module, we're going to be discussing copper pipes and fittings that we find in the plumbing industry. And there are some differences between what industry you're in, but copper, of course, is made out of copper alloys, and it's used for multiple different things. And copper does have some unique characteristics why we use it in plumbing. So this section here, we're going to be covering types of copper tubing and fittings. The objective of this section is really to identify the types of copper tube and their uses, describe the sizing and labeling of copper tubing, describe the different types of fittings used on copper tubes, identify storage and handling requirements for copper tubing. And there will be a performance test in this section, and we're going to select the types of copper fittings that's used in the plumbing industry. And also we're going to identify types of fittings, valves, and their uses, and we're going to discuss why it is done a certain way. So again, we said types of pipe. That's what it's categories. We find copper piping, and we call it type. And the type really has to do with the wall thickness and the amount of pressure the pipe can actually handle. And actually, we call it tubing when it's copper. But if you call it pipes, other people will know what you're talking about. But the true name is called tubing. So the history of it's been used for quite some time. It was more considered on a high end, but after years of use of other types of pipes, they found out that copper tubing has some great characteristics, such as it doesn't rust out. It doesn't build up minerals on the inside of the piping, such as other pipes like galvanized pipes, which will hot water lines will completely plug up with minerals. The second thing, black pipe will rust out in a short time. So copper doesn't have those characteristics. Plus, another thing about copper, it doesn't grow algae or other plant life, organic materials on the inside of it. It's inert materials that works out really well. It's definitely more expensive. It's been used for quite some time. And the thing is that understanding the piping, there's many different fittings, the same type of fittings you find with other types of tubing and pipe. The difference with copper, we don't thread it. We will solder the pipes, which we call sweating. And so when we look at these different type of fittings, it's just really just joining the pipe together. It's faster to actually install than let's say threaded pipe. One of the reasons is because you don't take that time to set it up on a pipe vise to thread it and so forth. However, we do have to sweat the pipes. So copper tubing comes in 5 different types, and the highest grade is K. The next is L, M, D, W, V, A, C, R. And let me explain the difference. K pipe is heavy wall thickness. It's designed for higher pressures that you may find in factories or hospitals where they carrying gases at a high pressure, and that K pipe will be able to handle those higher demands of pipe use. L is probably the most common used for a variety of things. Matter of fact, it can be used for things that's under pressure, for sure. You can definitely use L. Um, and matter of fact, use L up to 400 or 500 pounds of pressure. Um, Typically, we can use definitely for water lines, which is not nowhere close to that. M is a thinner wall thickness, and M, um, we can use it for pressure, but not very high pressure. We can use it for water lines, but we certainly don't want to use it for something over a couple 100 pounds of pressure. So DWV is definitely not used for pressure. It's used for drain, waste, and vent pipes, which is basically considered a non-pressurized piping. It's a thinner wall, and it's used these days. You may find it in commercial buildings, but it has become less used because of plastic piping. We discussed PVC piping used in the Midwest pretty much extensively for drain lines because it's faster to install, it's cheaper in cost, and it's very durable. And the last type is ACR. And this ACR is designed for the refrigeration and heating, air conditioning, and refrigeration industry. It typically comes in type L, wall thickness. But ACNR, because refrigeration pipes must be extremely clean on the inside of it, cannot have debris or dust or other things because it can contaminate a refrigeration system. So the piping for ACNR will have caps on both ends. When you buy it, both ends will be capped off. There'll be a plug in it or some type of cap. Plus, they will run a nitrogen through the pipe to purge out any oxygen, so the pipe doesn't oxidize on the inside of it. So they will purge nitrogen through just to make sure that moisture is not inside of that pipe. So moisture, air can contaminate a refrigeration system. So the system has to be extremely clean for that purpose. So again, ACNR is usually type L. You can actually get it ACNR type K, but you will not find M for ACNR. And ACR stands for air conditioning and refrigeration. ACR, air conditioning, refrigeration. So you see that we know that it is used for that special purpose. And again, for like in hospitals where they run oxygen lines and other type of gases through piping, copper tubing, it's typically ACNR too. Here's a warning. So always check for electrical grounding when working with copper tubing. Copper water pipes lines are often used as a electrical ground, and that's true. Um, they will ground the water pipes because it goes into the ground and it goes for hundreds or thousands of feet into the ground, um, going across the ground to give a really good connection. So if there's ever a short into the house, something becomes ground faulted, it can dissipate that energy into the ground. And so water pipes are always, unless it's plastic piping, such as PEX tubing, it may not be ground. Well, there's no reason to ground it because it's insulator. But if it's copper pipes or galvanized pipes or metal pipes, it will be grounded. So copper water supply lines are often used as a electrical grounding. Always shut off the electrical power if you break the ground. When you shut off the electrical power, always use approved lockout tagout procedures to avoid electrical shock. Check with your your immediate supervisor before proceeding whenever electrical power is applied. Okay, we're looking at the sizing. I explained the difference already. Here's the thing, the outside diameter of the pipe do not change, but the inside diameter will change. So tubing sizing varies depending on the type of copper tubing. Types KLM, DWV use nominal, or what we call standard sizing. In other words, the outside of the pipe do not change, but the inside of the pipe will change. This means that the outside diameter is always 1/8 inch larger than the nominal size. So the nominal size will be the inside diameter. The nominal size is approximately measurement in inches of the inside diameter for most copper pipes. Type ACNR uses actual outside diameter, and that's true. So HVAC, heating, ventilation, and refrigeration technicians will always use the outside diameter, and that ACNR pipe comes in a lot more sizes than plumber pipes, because the refrigeration systems require to size the piping correctly for the flow rate of the refrigerant that's going through the piping. So again, HVAC technicians use the outside diameter while everyone else uses the inside diameter as their nominal size. And this another thing too is that to be able to recognize the type of piping, yes, they were printed on the pipe, but to visualize it very quickly, they will color code the printing on the piping. So you will know just as at a glance what type of pipe you have, what type. So K would be green printing, L would be blue printing, type M would be red printing, DWV would be yellow printing, and ACNR, it would be blue, because like I said, that it is typically type L. But you can find type K ACNR too, and the printing then would be green. In this picture here, you see all different types of fittings, and these fittings are for joining the tubing in multiple different positions. And some of these fittings are kind of unique, so it can take threads. For example, let me see if I can use my laser to point something out. Doesn't look like it. Okay, well, there we go. This is actually a union joining two pieces of tubing together to make a connection. Usually we use unions where there's devices like valves or some type of fitting, so you'll be able to remove it very easily by loosening up the union. Other things you may find would be like male adapters. This male adapter here has threads on one side and you sweat on the other side. So you can actually go into a threaded fitting with copper pipe. So this is we call a male adapter. This fitting here is a female adapter. It has inside threads, and you should be able to thread that onto another fitting or pipe that is already has threads on it. And these are the other fittings such as elbows, 45-degree elbows, street 45s. Street, remember, it has a fitting that has a female fitting on one side and a male fitting on the other side. That's what we call a street elbow. In a trade, we just call it streets. And the compression fittings. So almost anything you can find with other types of pipes, you can find it with copper pipe also. So Here's the thing, and this is true with any type of pipe, not just copper pipe, is that use as few fittings as possible. The reason is every time you put a fitting in, a fitting, if there's flow rate going through a pipe or tubing, every time it makes a change in direction, it adds restriction to the flow rate into that pipe. Restriction and can reduce the flow down. So by using as few fittings as possible, it will help with full flow into something. And most of the time with water systems, it's not that big of a deal. Unless it's a high-rise office building or something like that, or very long runs where it can affect. But in the house, fittings, or if you have to put a lot of fittings in, you can always size the pipe to the next larger size. The next larger size will help reduce that resistance from the fittings. So transition fittings such as dielectric unions, and I'll explain that in a second, prevents electrolysis. And dielectric is, for example, galvanized pipes is coated with zinc, and zinc and copper affects each other. Matter of fact, in time, it can actually corrode a copper fitting. So a dielectric fitting actually have a brass fitting on one side for the copper piping, because brass and copper is compatible. And on the other side, they use a gasket to separate the other side of that fitting, of that union, with a rubber gasket, and they will have metal like steel pipe on the opposite side of that dielectric union. So it'll be brass, which is compatible. They use a gasket to connect it, and then they will go to the steel pipe. So now the galvanized pipe will not affect the that copper pipe. So you find dielectric unions like on water heaters, where the water heater may have on the top of it, a nipple coming off the top of it for both the hot water and cold water. That nipple usually is galvanized so it doesn't rust. And then if you ran copper pipe to your house, you will, at that point, use a dielectric union to go to copper. Two kinds of solder fittings are available with copper tubing. Again, two kinds of copper fittings. And so it could be a copper fitting, or it could be a brass fitting, either one. Brass is compatible. So if you're going to solder, it can be a brass fitting that you can sweat into. These are common type of valves that you can use, and these valves are usually bronze or brass that you can use copper. So it's the same type of valves you've seen other uses. However, it would be brass, so it doesn't have that electrolysis. This particular valve here is a compression fitting. The valve is brass or bronze, but it will have we call a ferrule. Ferrule looked like a wedding band. It's kind of tapered, and this nut on it would tighten up on both sides to be able to connect it to the copper pipe. And so that compression fitting is a very good fitting. It's tight. The nice thing about it, it's easier to remove than a copper fitting, because all you have to do is unloosen up this nut here, and you'll be able to remove the pipe from the fitting. DWV fittings, again, these are light duty fittings that's designed for drain, waste, and vent, and they allow liquid and other materials to flow smoothly through them. Copper is a really smooth material, and it has very little resistance compared to like galvanized pipe or black pipe. And because of copper, the pipe's the nominal size inside of it is not as large as a black pipe or galvanized pipe. So that's why you can have two different sizes, or it looks like, well, physically it's two different sizes. If you look at a half-inch galvanized pipe and a half-inch copper pipe, that copper pipe is a lot smaller. It's probably almost about half the size of it. But the galvanized pipe is actually larger because of the resistance inside of the pipe. So it's actually larger than a half inch. So if you got a half inch galvanized pipe, the inside diameter is definitely larger than um, than a half inch in physical size. So these are some other fittings that you're going to find in a field. Sweat fittings are common. Now, they're coming up with a lot of other type fittings, these press fittings that is used to be able to join pipes together with a lot less effort without sweating to speed up time. And some of these pressed fittings, they work extremely well, and it's a fraction of the time to install them. So you can actually pipe in a job a lot faster than you in the past. So press fittings is one of them. A bullhead tee. There's mechanically formed tee connections. In other words, on the inside of it, there would be um, like a ring that actually holds the pipe together, keep from sliding off, to keep it from coming apart. But there's an O-ring inside of it that will cause a mechanical seal inside of it and hold the pipe. Of course, these fittings are a lot more expensive than a normal tee, a sweat tee. But here's the difference. The time you save in labor, the time you save in labor. If you're paying somebody to pipe in a job for you, you're paying them, they are journeymen making very good money. And if you can help them to complete a job in a lot less time, that time savings will offset those costs of the fittings by far. These are the, well, some people call them shark bites, but these are shark bite is a brand, but other brands make these too. But these are these press-on type fittings too, that you don't need a special tool to crimp it. This you just slide on and it would bite into it. And it's come in all different types of fittings. So whatever fittings that you can use with regular tubing, you can certainly use it. Shark bite for the same thing. These are just even more expensive. And okay, these are the press fittings. Um, these are copper fittings. This is an elbow, this is a reducer, this is a T, all the same fittings. And it looks a little bit different because the O-ring inside of it, that O-ring will seal. However, you cannot just slide it on. You have to use a tool to be able to crimp that fitting around the tubing, and it will seal it. And the tool itself is expensive. Um, so I wouldn't use this or buy the tool unless you do this on a daily basis, that you are doing construction, because you end up spending over $1,000 easy for the tool and buying the fittings and so forth. And when you could just buy the fittings, the sweat fittings, and just be able to sweat them in, solder the fittings in. All right, warning. It says always work under the direct supervision of your instructor or foreman, and always practice safe precautions to protect yourself and your coworkers from injury and to prevent equipment damage. Do not try to do any work that you have not been specifically trained to do. The reasons why, you might make a mistake. You may cause harm to yourself, harm to someone else, or harm to the equipment. So again, if you don't know, ask for training. For example, do not operate valves unless you know exactly what the results will be. Before you work independently on a system, you must know the temperature and the pressure conditions that exist in every point of the system, and how those conditions can be affected by malfunctions, by in a position, out of position, that of the valve. Hey, and that's true. I've seen guys who do things and they didn't realize what was behind their actions. I've seen things that will that didn't go right because of someone actually opening up something or turning something on, not knowing what the outcome would be. Material storage and handling, just like any other pipe, we should store it. Keep, especially copper pipe, because it can oxidize. In other words, we see a penny, a brand new penny, is nice and shiny copper finish, but an old penny is really dark and dingy, and that's what happened to copper. Basically, that's oxidation. When that pipe changes color and become dark, it will not be able to be soldered. It will not stick to it. You could not use your solder to join it to. It would just run off of it. So copper pipes has to be clean for it to have a good fitting when you're sweating it. So take proper steps to store copper securely and ensure that the building is locked at the end of the workday. Reason why? Copper expensive. People steal copper to sell, to scrap it. And so if you just don't take, I have been on jobs where people have stolen copper off the job. And of course it ends up at a junkyard, at a scrap yard. Store tubing and fittings near where you'll be working so they are easy to access. Organize the tube and fittings by groups by the tube size and type. Be careful not to bend or damage the tube and fittings. Here's one of the big thing. If you actually bend either the fittings or the tubing, it's not going to fit. And even if it's just even a slight bend, it will be extremely difficult to join it together, and even worse to solder it, to seal it. You've got a small dent in copper pipe. A lot of times that's where a leak would be. It will be a leak. Take extra care when working in cold temperatures. Okay, here's some terms we need to go through. ACNR, like I said, this stands for air conditioning and refrigeration systems. ACNR tubing is annealed copper tubing, which is hard. Annealed, meaning it's hardened. Copper tubing that is manufactured specifically for the use of air conditioning and refrigeration work. Annealing. Annealing is a process and slowly cooling it to relieve the internal stress. This process reduces brittleness and increase toughness. Bullhead tee is a tee fitting that used on a branch that is larger than the main line, or that has one outlet larger than the run openings. Compression joint is a method of connecting in which tightening a threaded nut squeezes the compression ring to seal the joint. Drawn copper. This tubing produced by pulling the tubing dies through its diameter. The drawing process, basically it brings the copper to the proper size and make it very rigid. So drawn copper is usually, we buy that in 20-foot lengths for job sites, and we'll cut it down or use the whole piece if it's a very long run. And so the drawn copper, many times what we buy. And of course, we know in supply houses like Menards or Home Depot, you only buy 10 footers. But from a supply house for contractors, we would definitely order it comes in a 20 foot. So when you get it, that's what they're going to give you. They can cut it down for you. They may charge you, but the typical length is 20 feet. A ferrule is a brass compression ring, I explained, look like a wedding band for a man. So it's a brass and it fits around the tubing, and use a compression fitting and a compression nut to tighten that ferrule on the copper tubing. Once it's tightened down, that ferrule cannot be removed. It becomes really part of that pipe. And it's made out of brass. So it's brass is a soft material, so it is malleable. So when it use a compression nut and a compression fitting, it actually joins it to the tubing. A flare joint. Now that's a special type of fitting that we use for copper piping. And certain joints, we have flare fittings. The end of the tubing is flared. And so we have a flare nut and a flare fitting. It's similar to a compression fitting. The difference is that it doesn't have a ferrule. And the other difference is that we actually flare the end of the tubing. I'll post a video to show you so you can watch to see what a flare fitting and a compression fitting is. But a flare fitting, we actually use a special tool called a flaring tool to be able to flare the end of the tubing. And it's a very specific process to flare the end of it. So it's a fitting in which one end of each tube to be joined is flared outward using a special tool. The flared tube end mates with the threaded flare fitting and are secured with the fitting with a flare nut. And these flare nuts is what we tighten down to the flare fitting. And the tubing is actually sandwiched between the flare fitting and the flare nut. It's sandwiched between it. And once I show the video, you'll be able to see it. For malleability is the ease in which the materials can be bent, and that's soft tubing. And it is we can bend that with a tubing bender. We can bend it with different types of tubing benders. We use that a lot of times in special work. Dealing with, matter of fact, plumbers use it too. A lot of times when in commercial jobs, when they're running supply lines to a sink faucet, underneath they got the stop valve underneath the sink, the stop valve to turning the water on and off, and then we have a supply line. Usually that supply line is 3/8 of an inch, and many times it's copper tubing, and we it may be a compression fitting on one end. It may be a flare fitting on one end, but we can, to be able to make a nice looking job, we will use soft tubing, and we will use a bender to bend it to place and to put it in place to make it look nice instead of hand bending it. Pressure drop. Pressure drop is the decrease in pressure from one point to another caused by friction loss in the fluid system. In other words, like I said, a lot of fittings, anytime there's a rough surface inside of the tubing, or if there's a lot of fittings in one run, it can reduce the pressure. There's a pressure drop, which will reduce the flow of whatever is going through that pipe. A sweat joint is the pipe joint made by applying solder and using a fitting to join the pipe to the tubing to the fitting. So basically using a solder and a flux and then heating that pipe up until that solder will melt and will fill that joint with the solder. Then we let it cool down and it hardens back up again. So the solder will, as a matter of fact, the solder has a low melting point, and so it will melt before the copper will melt. And matter of fact, it would melt a lot lower than the copper would melt. So we don't use a lot of heat, like in certain processes. We're not welding it. We actually what we call soldering, which is melting the alloy, which usually it's the metal we use for soldering these days is antimony and tin. Antimony and tin. Got some questions here, and we can go through these real quick. Drawn copper is produced by a blank. Drawn copper. And if you remember, it has to deal, so is it heating the piping? Heating the piping process is actually annealing the pipe. Cooling process is part of annealing also. We heat it up and let it cool down slowly. Pulling process, the answer is the pulling process. It's not pressurizing the pipe, but it's actually pulling. Copper tube used for DWV is marked with the color code of, and the three main colors you're going to find, well, actually it's 4 colors. And it's one of them not orange. But when it comes to DWV, it would be yellow. Yellow. Which of the following is true with regard to fittings? A says fittings can be used to reduce pressure drops. B says use as few fittings as possible. C says solder fittings are slightly smaller than the tubes to be joined. And D says sweat fittings are used with thread tubing. Okay, let's start backwards. D, that is wrong. Sweat fittings are not used with threaded tubes. A says fittings can be used to reduce the pressure drop. No, fittings actually add to a pressure drop. As a matter of fact, one fitting making a 90-degree turn can add about 2 to 3 feet of equivalent length of piping. So if we got 5 fittings, that's like adding, let's say, 15 extra feet of piping, the resistance of 15 feet of piping. C says solder fittings are slightly smaller than the tube. No, the solder fittings are larger because we slide the tubing inside of the fitting. So the correct answer is use as few fittings as possible. The next question says, take extra care when working with copper tube and cold temperatures because it can blank. A says it can break. B says can shrink. C says injury to bare hands, injure bare hands. And D says it can corrode rather. Can corrode. The answer is injure bare hands. Now here's the thing, copper tubing is a good conductor of heat. And the heat can leave it and be the same temperature as the air temperature around it because heat travels from a warm source to a cooler source. So again, that copper can suck that heat out of your hands very quickly. Copper is an extremely good conductor of heat energy. It can extract the heat. It's holding cold copper, and so compared to other materials. So again, since it's a very good conductor. Your hands are warm. Copper tubings are very cold outdoors in cold temperatures, so you must be careful.